Hi, it's Mr. Brewer here today, bringing you a lesson today on what we call limiting and excess reagents, sometimes called limiting and excess reactants. These concepts or terms will eventually become mathematical ideas, but I'd like to start with the understanding from the perspective of what actually happens to particles when a chemical reaction occurs and why a chemical reaction stops. Essentially, what happens is we run out of one of the particles, which is what we would call limiting, and that limits our ability to make any more new chemicals called products. What's left over as reactant, we would call the excess reagent. What we have below here in the circle is a simulation of particles available as reactants. The particles available will get used up in a very specific ratio. That ratio is represented by what we call coefficients. In this case, when we look at the coefficients, for the element iron, there's a coefficient of 4, and for the other reactant known as oxygen, there's a coefficient of 3. This essentially means that these particles, when the chemical reaction occurs, they occur in a 4:3 ratio. Thinking about this, what we can do is we can begin to cross off particles in a 4:3 ratio to determine what we run out of. So we'll take away 4 iron. As we do that, we have to recall that takes 3 oxygen with it. You may be asking yourself how we knew which of these particles represented iron and which represented oxygen. Well, we can tell by looking at the chemical formula. For iron, there happens to be no number following it, which means iron is an element represented by individual atoms, or the blue spheres here. Oxygen, however, is a molecule represented by 2 atoms of oxygen bonded together. Therefore, the tiny white circles represent our oxygen molecules. Let's continue the 4:3 ratio. So we'll take away 4 iron, and we'll take away 1, 2, 3 oxygen. And it looks like there's still plenty of chemical left. We'll take away 1, 2, 3, 4 iron, and 1, 2, 3 oxygen. And notice now we have completely run out of oxygen molecules. Therefore, oxygen is what we would call our limiting reagent. And iron, which there is leftover quantity of, the blue spheres, is what we would call our excess reagent. If you notice at the bottom of the screen here, I've labeled iron as our excess because there is extra quantity of particles of iron left over, and O2 is limiting because the oxygen has been completely used up. Let's try this again with a different chemical reaction. Again, one reactant known as barium oxide, the other reactant, which you'll recognize as water, or H2O. Now, in this case, there happen to be no coefficients written in front of either of these reactants. Therefore, the ratio they combine in is 1:1. So let's begin combining them in 1:1 ratio. Well, it appears to me that water will be our 3-atom molecule here, 2 H's and 1 O, and barium oxide would be a formula unit made of 1 barium and 1 oxygen. So let's begin combining a 1:1 ratio. 1 for 1, 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 1 for 1. Sounds a little repetitive. 1 for 1. And it looks to me like we have run out of one of the chemicals here. In this case, we've run out of water. So if you look down at the bottom of the screen here, we've determined that H2O, water, is limiting because there are no particles of water left. And barium oxide, it looks like we have this labeled incorrectly. We'll have to change that. So we will change this to BaO is excess because there is extra quantity of that left over. I'm going to suggest you pause this video to try the next example. Before you start, make certain that you're considering just the reactants, C2H2, which is a chemical known as acetylene, and O2, which obviously is the element oxygen. Take note of the ratio represented by the coefficients. Pause the video and see if you can determine which is limiting and which is excess. I'm thinking you probably got about this far. You're going to notice that there are 2 oxygen molecules left over and 4 acetylene molecules left over. We might think that this means that they are both limiting, or the both excess, because there's extra quantity of each left over. But recall again, the ratio necessary to proceed would be 2 to 5. It appears we have 2 acetylene molecules left over, actually a total of 4. 1, 2, 3, 4, but only 2 oxygen. We would need 5 oxygen molecules to proceed. Therefore, I think it best to perhaps describe oxygen as limiting in this case. If we call oxygen limiting, then we would assume acetylene would be our excess. Again, you'll see near the bottom of the screen that I've identified O2, or oxygen, as limiting. Let's have you pause the video and try it with our last example here. You have the elements aluminum and the element chlorine combining to make a new chemical called aluminum chloride. Pause the video and determine which of the chemical elements in this particular reaction are considered limiting and which are excess. I'm hoping that you've revealed there's extra chlorine, represented by the molecules here, 2 chlorine atoms bonded together. Therefore, it appears that chlorine is our excess, and aluminum, which has been completely used up, represented by the blue dots, is what we would call limiting. This concludes our lesson on the limiting and excess reactants, or limiting and excess reagents, as some like to say. In the future, what will happen is these ideas will become mathematical ideas, but I felt it best for us to understand the concepts before we looked at the mathematical nature of this. I believe that this makes good sense for students to understand the concept before we begin to manipulate mathematical expressions that relate to determining what is limiting and what is excess, and how much specific quantity of limiting and excess we may actually be talking about. Until the next time, signing off, this is Mr. Brewer. Thank you for listening.